Hi guys, I'm going to show you how the CSS detector works. First of all, our project is used to locate possible fracture points of an X-ray photo. This detector is based on CSS corner detector. The first step of the curvature scale space algorithm is to extract the edges of the bones from an X-ray photo. We tried many different edge detection algorithms, but of course, canny edge detection proved to be the best one. Because most X-ray photos are not clear and always come with organs and muscles, very tissue caused errors in the canny edge detection, resulting in many broken up edge pieces that aren't part of the border. Thus, it is necessary to apply a sharpening to the canny edge detection to ensure it extracts the border as completely as possible. There were still a few gaps in the resulting edges, so the code here is for gap filling. Gap here means if an endpoint is nearly connected to another endpoint, so here we search all points that 2 pixels away around an endpoint to see if there is any endpoint, and if there is, fill the gap up. Here's an example. Figure 2 is the edge contour of sample 1. We can see there are several gaps, and after the gap filling, some gaps have been filled up. The next step was to format all the points of the edge into a consecutive list. Each next coordinate in the list is the next point along the edge. I have a function for this. The function takes in the binary image of the contour and outputs a list of consecutive points. To make the start and end point consistent, then the discrete curvature is computed for each list of edge points, using the formula from the notes. Now we have a list of edge points with their curvature. For an X-ray photo, a sharper angle is less common, so theoretically, the point with the largest curvature is supposed to be the fracture location. But actually, the accuracy of the detector highly relies on the quality of the contour, and it is hard to extract a perfect contour from an X-ray photo, so we decided to choose up to 3 points to ensure the detection. And when we count the location, those points that close to each other will be excluded to avoid repeated detection. Now let's see 3 examples. In order to get the best contours for each example, we adjusted some parameters such as thresholds and the number of corners. There are still some limitations. The first one is about the edge extraction. This algorithm depends heavily on the edge extraction, although we use canny edge detection, one of the best edge detection algorithm. It is still hard to get clear edges from X-ray images, and that will have a negative influence on the detection result. So far, all the samples that we used are arms, legs, and fingers and toes. They are all clear structure among the entire skeleton, but this method doesn't work well on some complex structure like chest. And there are some potential improvements as well. So far, the gap filling algorithm only fills the gap between 2 pixels that have a distance of 1 pixel. For improvement in the future, we can fill the gap with more than 1 pixel. And an algorithm about detecting whether two endpoints should be connected needs to be developed. And the second is to improve the quality of X-ray images for detection, we can also increase the contrast of the image to make bones brighter and make the other parts darker. And the last one is the reason why it's difficult to apply this algorithm to those structures like the chest is because there are so many noises in the X-ray images. It is possible to develop a method to remove noises on these X-ray images so that